Bloody hell, today is Monday, guys, and that means another episode of the Wild Science Commentary. My name is Lorenz, and as always, I prepared a highly exquisite paper for you. What are the differences between organic, biodynamic, and conventional farming? We will find out, we will see in this paper, and if you like the kind of content, then ring the bell down below in the corner, hit the subscribe button. That's it from my side. Alright, another week, another paper. This time it's called Growth, Yield and Fruit Quality of Grapevines under Organic and Biodynamic Management. Head researcher here, Johanna Doering, works for the Department of General and Organic Viticulture at the University of Geisenheim. This paper was published back in 2015 in this PLOS 1 journal, which is a peer-reviewed open access scientific journal. Let's have a closer look at the researchers. Dr. Johanna Doering has a PhD, obviously works as a researcher and as a lecturer at the University of Geisenheim. Her expertise clearly lays in this biodynamic, organic field. Contributed to a bunch of research, also conducted a bunch of research. And furthermore, as I found out, she and her husband, who actually is also a researcher at Geisenheim, they own a small, very small, tiny winery in the Rheingau Valley where they produce some wines. And I like this scientific approach combined with the practical approach. That's what a lot of researchers are lacking on, but just my opinion. This are the wines of them. Very nice labels actually, puristic, organic, nice stuff. Haven't tried anything, maybe in the future. Back to our paper, guys. Introduction here. Demand and production for organic crops have been growing exponentially in the last few decades around the world. Very true. And worldwide, 2.3% of all vineyards are managed according to organic standards. So not much at all if you consider that there are 7.5 million hectares worldwide under vineyards, and 2.3% equals out in about 170,000 hectares. So that's viticultural size of Portugal, for instance. Not much at all. And then the biodynamic agricultural movement started in the 1920s and has been further developed. There's a Demeter label, which we all know, biggest biodynamic label worldwide. And then research on organic and biodynamic viticulture. Only a few studies consist which compare these organic and biodynamic practices with standard conventional practices. And then here they, for instance, state that the major effects of organic compared to integrated or conventional viticulture are, for instance, soil microbiological activity, which is increased, or increased soil organic carbon, decreased growth expressed as pruning weight, and so on, reduced shoots, decreased yields, reduced berry weights. So a lot of negative factors here, so to speak, and increased production costs, of course. And also they say here that grape composition, wine quality, and wine sensory characteristics are less influenced by the management regime. And then biodynamic viticulture showed reduced yields, and so on and so forth. And then current study actually found that red wines from biodynamic production showed decreased alcohol content, decreased phenolic compounds, decreased wine color, decreased total polymeric pigments, and decreased tannin concentration. So no positive facts at all. The aim of this study was to compare different management systems. Of course, organic compared to biodynamic compared to integrated systems. And this was done over 3 consecutive seasons from 2010 to 2012. Materials and methods, guys, as always, a small PowerPoint done by myself, which is just easier for you to understand what they did. So in this case, they used a complete block design rather than a randomized complete block design, because you have problems with spraying, drift, and so on. So in this case, as I already said, the experiment took place at the University of Geisenheim. Geisenheim also studied there, so I know a bit of history. And they have own winery, 23 hectares, I guess, or something like that. And in former times, the students called it the winery Chateau Sulfite, because here the manager at that time, he was one of those old guys. He loved the usage of sulfur in the wines, of SO2, of course, and these wines had a certain touch with of sulfur. Nowadays, for sure, it's improved because it's not there anymore. However, just a small anecdote. So the experimental site here was 0.8 hectares. So the vineyard was planted in 1991, and the conversion to organic viticulture started 2006. So before, this vineyard was farmed conventionally, but then you need 3 years of conversion time in order to execute your research. So this was then conducted over 3 years in 2010 to 2012. So you have 3 years of data collection, the longer the better. 3 years is optimal, I would say. And of course, guys, Germany, they used the Riesling clone here, GM 19830. So let's look at the design. They had 3 factors, of course. They wanted to compare the integrated, the organic, and the biodynamic viticultural approach. And each factor or each block was again divided into 4 plots. So every treatment replicated 4 times. And then each plot here was further subdivided into 2 subplots because they used 2 rootstocks. So SO4, selection optimum 4, one of the most used rootstocks worldwide, quite vigorous, medium plus. And then also they used the burner, which is quite vigorous, more vigorous than SO4. And yeah, this they did over all the 3 different treatments. And then each plot consisted of 4 rows, and every row consisted of 32 vines. And you have to see that they only used the most inner rows, and they excluded the outer rows because obviously you have some synthetic or some fungicides in the integrated spraying systems, which you don't want to have them to fly over to the organic and biodynamic systems. So this is just a standard approach that you do in research to exclude, to have some buffer zones, so to speak. So far so good. Back to our paper, guys. Down here, table 1, overview of the different farming systems. So in the biodynamic and the organic farming system, they use the so-called Wolf mixture as cover crop. And so this is very popular in Germany. Basically consists of about roughly 70% of legumes, such as beans, such as clover. And as you know, legumes are able to fix molecular nitrogen from the atmosphere, and then when they are disrupted, they provide that towards the plants. So you don't need any mineralized fertilizers here, but that's it. And in the integrated system, they used a standard grass mixture. Okay. Under vine management was done mechanically at the biodynamic and organic approach, whereas herbicides were used in the integrated approach. And then fertilization was done with compost for all the 3 treatments. But as I explained before, you have a bunch of leguminoses here in the Wolf's mixture at the biodynamic and organic approach. And in order to make up for that, they calculated the amount that the vine would approximately have, and they gave that amount to the integrated farming practice in terms of, or in form as a mineral fertilizer. So basically all 3 treatments had more or less the same nitrogen, so to speak. And then plant protection was obviously done with copper and sulfur at biodynamic and organic treatments, and some systemic fungicides were used for the integrated system. And then, guys, as you might know, if you want to farm biodynamically under the Demeter label, then you have to use at least once a year the horn manure, so the preparation 500 and the horn silica 501. And if you use compost, then you have to inoculate with the preparation here. So this is the main difference between biodynamic to organic farming. Of course, there are some other differences, but there's obviously not a big difference from organic to biodynamic. So far so good. And now we're gonna look at some results. Big paper, massive paper, 28 pages. I'm not even sure, it might have been her dissertation, not sure. However, so in terms of lateral leaf area per square meter per vine, the highest significant values were found at the integrated treatment here. Same for the overall leaf area index, highest value here again, integrated system. Pruning weights 4.4 tons, guys, at the integrated systems, whereas the organic and biodynamic systems you didn't see any significant difference between those two. They had lower values here, and also relative chlorophyll content aberration, highest level at the integrated system. So you see overall these are pruning, or these are growth indicators. So you see that the vigor was quite decreased in these organic and biodynamic farming systems. In terms of nutrient status, this was sampled as N-min. So N-min represents the available nitrogen per kilogram and hectare at a certain time point. And you see here we have the lowest levels of available nitrogen in the integrated system, whereas the organic and biodynamic systems had quite elevated levels here, significant different to the standard farming practice here, which means that, or with other words, we saw before that there were a bunch of legumes introduced here in these farming systems, which apparently provided all the nitrogen to the plants. And when you use legumes, guys, legumes are very powerful nitrogen providers, up to 400 kilograms per hectare in some cases and year. So if you plant too much of or only legumes, then you might have a nitrogen leaching, and your vine is just out of balance. Okay, so keep attention to that. And this trend also is followed in nitrogen content in leaves in percent aberration, highest levels, biodynamic and organic farmed treatments. Physiological performance, guys. We see the assimilation rate, which is the fixation of SO2 per square meter and second. So the photosynthetic capacity, so to speak, is the highest in the integrated system. Then the transpiration rate, so the water loss throughout the stomata, again highest in the integrated system. Then the stomatal conductance, which is the gas exchange of H2O throughout the stomata, which expresses basically if a plant is stressed or not. The higher the level, the less stressed a plant is, because it doesn't close the stomata. Stomata are open, so the vine still works. So there's water in the soil, for instance. And pre-dawn water potential, we see the more negative the value, the more stressed the plant is, the less water it has available, and we see the lowest levels or the more negative values here in the organic and biodynamic treatments. And now, guys, in terms of yield, we have almost 7 tons per hectare in the integrated system, and the biodynamic and organic systems only provided 60% of that, so 4.3 tons per hectare. So the crop was massively reduced. Cluster weight, same, lowest value in the organic and biodynamic systems. Cluster compactness, okay, the highest values we have now in the integrated system. And then let's have a look at the disease incidence. Plasmopora viticulata, so peronospora, the highest disease incidence in the organic and biodynamic treatment. And in terms of botrytis, we see the same trend with the highest values in organic and biodynamic treatments. And then this is interesting, sour rot. We have 9-fold the value, or 8-fold the value of the organic treatment in the standard treatment, meaning the cluster was just too compact, which means the berries were squeezed, and then you end up with some sour rot. Probably this was the case here. And then in terms of wine grape quality, guys, no differences in TSS and Brix. In total acidity, no difference. pH, no difference. And then NOPA, so alpha amino acids available for the yeast at fermentation, we have some differences. We're gonna look at that in a second. Let's scroll down here. Yep. Okay. So in these 3 charts here, ABC, we see the average single berry weight over 3 seasons, and we see a clear trend. Integrated farming system, highest average berry weights over all years. But these charts, DEF, they express NOPA values in the grapes for the different farming systems. So literature suggests that you should have around 150 milligrams per liter of NOPA, so alpha amino acids, for the yeast in order to complete fermentation. And we see the highest value in 2010 in the integrated system, in 2011 the highest value in the biodynamic system, in 2012 we see the highest value again in the biodynamic system. Interesting so far. Okay guys, that's it. We're gonna look at the discussion. So in terms of growth, we saw that lateral leaf area index, pruning weight and so on was of course increased in the integrated system and reduced in the organic and biodynamic system. And then they basically say that the organic and biodynamic treatments showed higher nitrogen content, expressed as N-min, and also higher nitrogen content in the leaf tissue at variation. So therefore, nitrogen content was not the limiting factor which resulted in this limited growth from the biodynamic and organic treatment. Assimilation rate, transpiration rate, stomatal conductance are significantly higher in the integrated treatment in the growing season 2010 to 2012. Yeah, it can be deduced that integrated treatment had higher whole plant assimilation and transpiration because it showed higher lateral leaf area and higher leaf area index. Okay, that's why these factors here were increased. That's their conclusion. And furthermore, they think that because we saw nitrogen was not the limiting factor leading to reduced growth, it might have been water, because in biodynamic and organic farming system we had the inclusion of the wolf seeds, so the wolf cover crop, meaning this cover crop consumes a bunch of water which is not available to the vine, and this could have led to the overall decrease in growth. Okay, it was not the nitrogen, might have been the water in this case. And then furthermore, copper used as active ingredient in spraying agents against downy mildew might possibly influence physiological performance of organically and biodynamically grown vines and thus growth. So I didn't know that, but apparently copper can have a negative impact on growth. On the physiological performance, meaning for instance assimilation rate, transpiration rate and so on. And then in terms of yield, we saw 34% reduction or 35% reduction respectively from the organic and biodynamic treatment compared to the integrated treatment, which was partially explained by the reduced cluster weight, reduced berry weight, and increased disease frequency of downy mildew. Wine grape quality, we saw no differences in TSS, pH, TA, but we saw some differences in the NOPA concentrations. So one reason for the lowest concentration of NOPA in healthy berries of the integrated treatment might be the application of systemic fungicides. So there was this one study that found that botryticides actually lower the NOPA values in the final harvest crop. So here up to 11 out of 6 analyzed amino acids in grapes were significantly reduced. Quite interesting. And then they say, on the one hand, if you apply botryticides, you have more healthy berries, so you kind of increase the NOPA again. But on the other side, you have the botryticides which lower the NOPA content, so you have this opposite effect, so it equals out again. Interesting. Conclusion, the organic and biodynamic management systems showed decreased overall growth, but fruit quality was not affected. The use of biodynamic preparations had little effects on wine growth and yield, and since physiological performance was significantly higher under integrated management, it can be deduced that it influenced both growth, cluster weight and berry weight, and therefore yield levels. In 2 out of 3 growing seasons, disease incidence and severity of downy mildew in the organic and biodynamic treatments partially accounted for yield reduction in the respective treatments. Wow guys, long paper, I know. Some references at the end. And what is our take-home message now? So the most important fact is actually that in the organic and biodynamic treatments we saw reduced growth or reduced vigor expressed in a reduced pruning weight. And then also we saw increased disease incidence, in terms of Plasmopodda viticula in the organic and the biodynamic system. And then obviously, guys, the yields were massively decreased in those two systems, meaning that if you farm that way in a cool climate that we have here in this case, then you have problems with the economics. Okay, so just keep that in mind. But of course, if you go to a Mediterranean climate and you farm there, like in a Napa Valley, for instance, or in the Languedoc-Roussillon, that is a complete different situation, and you don't have Plasmopodda viticula there as much as in Geisenheim, of course. And yeah, so far so good, guys. I hope you enjoyed it. That's it.
What a long paper, guys. I know life is not always easy on us, that's how it is. Nevertheless, I hope you liked it. If so, hit the subscribe button down below in the corner, of course. And stay tuned for more next week. We will see which climatic conditions in the past led to 100-point Burgundy rating. Very interesting paper again. Guys, stay safe, stay hydrated as always. See you next week.